Hello, welcome to the command pattern video. This video is to demonstrate implementing a command pattern into a real-life actual project. It's a dead simple project, but it is a perfectly legitimate structure and way to approach something. So this is a real-life situation, even if I've cut out all the unnecessaries. So let's start with what this game is. This is a a game where you move around on a grid and push blocks. If you know anything about the types of games that I tend to make, you'll think, yeah, that sounds about right. I've been working for a long time on a game where you move around on a grid and push blocks. Although I have, many more things going on. One of the things I have in this game is full undo support. Full undo support. And pathfinding, fancy. So I make a mistake, and I can't cover this area. I can just undo all the way. And one of the advantages of the command pattern, sorry, I can't play and talk at the same time. One of the advantages of the command pattern is it allows us to undo a move. It allows us really to contain a move in action, a single action or command that you could execute and contain it as its own object. And once you have it as its own object, you can store it in a list, and then you can add and remove from that list, adding all the things to the list and doing them. And because you store them over time, they can know about themselves. They can know about what they do, and thus can know how you undo it. And that's the big difference between the command pattern and maybe a very similar undo stack with your inputs, right? If I record all the player's inputs as directions, right, and I say, oh, time to undo. Well, let's just do it in reverse. Opposite of right is left. I hit undo and I go left. But that block I pushed doesn't come back with me because it doesn't know about my history. Because the move doesn't encapsulate everything that move did and how it affected all these other objects. So the command system allows us to encapsulate all of that information about a move into one place. And that's pretty great. You don't have to use them for input commands. You can use them for all sorts of things. But it is creating an object to represent like an action or a verb, and then using that. So we're going to use it here to add undo support to our little Sokabon game. Sokabon, look it up. Look it up. Read through the Wikipedia page. Sokabon's great. Everyone loves Sokabon. It's the best game ever made. Okay. So let me show you the project we have here in front of us. So the game is Sokabon. We're doing a command system, and here is the code. We have a block player and a level manager. Level manager just restarts the level when you press the R key. Not important. The block and the player are the interesting bits. We'll start with the block. The block has three functions we actually care about. One here is just I was copying, pasting some code all around, so I just wrapped it up in its own little function. We have a function that moves us in a direction, and that just sets our position. It just directly sets it. But later, if we wanted to have this thing animate, we could overwrite this code and just change it, right? The logic is right here. The block controls how it moves. There we go. Next, we have two sort of questions that we ask. Is the direction free? Is there nothing in front of me? That does a physics check on position, and then it tells us if there is nothing there. And next we have, is there a block in a certain direction? And if there is a block in a certain direction, or is a component that has a block collider, it'll return that block component. If it has a 2D collider, and then that same game object has a block component, it'll return that block component. Otherwise, it will return null, and we will return null. There's a better way to write this. We can do both of these in one check using an out variable, but we haven't learned that, so we're doing it this way. Okay. Next is the player. The update script just says when we push a button, we should move. So there's our player input script. I put them both in one script like I teach you not to do. But it's like two functions here. It's very simple, so I didn't feel the need to split it. although while I'm thinking about it, I really would like to add this action. Just while we're looking at the code, I could pause the video, but I won't. I want WASD. Okay. So we move and we receive a direction and we move. First, we see if there is nothing in front of us. And if there is nothing in front of us, then we tell the block, which can handle the movement, to move. If there is something in front of us, we check to see, we get the block in the direction. And if it is, if it's the wall, then it's not going to have a block component. So that's going to be null. And then won't do anything. But if it has a block in the direction in front of us, we can then see if that block can move. And if it has a free block in front of it, then we will move both us and the block. In a traditional Sokabon game, you cannot push blocks recursively. We cannot have our block push another block, push another block. You can only push one block. You get two, too much to push. So this encapsulates that logic. And it's not recursive, which is maybe a plus depending on your opinions about recursive functions. I think I might write this a little bit different, but who cares? I want the ability to have it, to choose the number of blocks I'm able to push as like a number. I would like that. So that means implementing it and then also complicating it on top of it. But anyway, that is the main logic of the game. I mean, that's the entire logic. The entire game is just in these two scripts. In Unity, our grid, we're using a tilemap 2D. Our tilemap has a collider on it. And that's it. Player, block. I have a little circle here, which is like cool, which is like once a block on top of it, but we haven't, I haven't there's no logic there for that. Just to make it look like a Sokabon game. We're not going to implement that in this video. So it's time to do a command system. I want to be able to undo, so I need to store my movements as commands. There are currently, I can look at my player script, I can see I have two commands here. I have moving myself, which I would want to undo as one thing, and I have moving myself and another block, which I would want to undo and have both of those undo. So I can make one command that takes a list of blocks, and maybe I give it a list of only one element. Or I can make two commands. And how do I write two commands? Well, that's where object inheritance comes in. We're going to write a base script that's just going to hold the outline of what a command is, something that can execute and undo. And then we're going to inherit from that and implement our specific logic for different types of commands. Let's start just with one. So let's make a new folder, and I'm going to call it command system, I guess. And we're going to make a new class. Not a mono behavior, not a Unity component, just a plain old C# object called a POCO, plain old C# object. So we're going to make an object, and we're going to call it command, and it's in our namespace by default. Thank you, writer, and it's there. What can a command do? It can execute, and it can undo. Now, I don't know, there's a little code smell. When I have nothing but empty logic on the parent class, I think, should this be abstract or should it be an interface? I don't know. But we haven't covered too much of that yet, so this will work. But you could make a command and then it wouldn't do anything, and that would be wrong. And we want our Git code to throw errors when we do things that are wrong, but it's fine. So we've got a command. It can execute, it can undo. Let's implement some specific logic for that. Let's add a new class and call it, I don't know, what's simple move? Simple move, move. Let's call it move. And it will inherit from command. And because it inherits from command, it can execute and it can undo. Great. So I need a way to tell it to take our block and move that move in direction code into here. So I need to know the block that's moving, and I need to know the direction it goes in. Well, we're going to store those as variables in the class. So we'll have a block for block, and we'll have a vector2int for direction. And that's pretty much everything that constitutes what a move can be, just that information. So let's generate a little constructor here so that we can create the block with this information. Ooh, what are constructors? Have we covered that yet? Maybe we should. Maybe there will be resources linked. I think we have at the time you're watching this. You're not, and if you're not, you're sitting there going, it's fine. So to move, we need to take our block, whatever it is, and call the move in direction code on the direction. And to undo, pretty sure we just do that in reverse, right? Boop. That's the code, move in direction and undo. So in our player script, instead of calling that movement code directly, we're going to make a new move, and then we're going to call the execute function on it in order to make it happen. When I make a new move, I use that same syntax, but you're thinking there's a little error here. And the error is because that is this new move thing. This is calling the constructor function. The constructor, it's not a function, it's a constructor. It's calling the constructor. So I need to give it this information. It's going to have this code happen when we create the object. So I can tell it here when I make a new move, I can tell it my block is this one. Nope, my block is underscore block. And my direction is direction. And now I have created it. It has been stores those variables, and then it just hangs out and does whatever it wants until it doesn't do anything until we execute it, and then it will happen. So let's test that works, because maybe it doesn't. It does. Great. Let's add the second movement command. So let's make a new class and call it, I think I can do this a fancy way. I think I can do create derived type. Aha, class, I want to create that in its own file, create derived type. We'll call it push block command, and I will move that to its own file. Great. What are you yelling me about? It's never used. Okay, well I haven't gotten there yet. It needs to be public. So what does a push block do? Well, it's going to be very similar to move, so I'm going to start by copying this code. And pasting it, and we're going to get rid of the constructor. But and then we need Unity Engine, I think. Yeah, we have a pusher block and a pushed block. And then I will auto-generate a constructor that all of these need to get passed in. Pusher, I don't like that. Great. And direction, what are you? Read only? Well, yeah, but fine. And we move our pusher object every time we move, but we also move our pushed object every time we move, and we can undo it. That's really the only difference. It does it to both, but it's all contained in one piece of information. You tell me this can be read-only. I know, but we're not gonna. One new concept at a time, please. Okay. So let's go back to our player, and we're gonna make. What are we moving? We're moving block, and we're moving B. Okay. Push block equals new push block, and its constructor is asking for the pusher, which is block. It's asking for the pushy, which is B, and it's asking for the direction, which is direction. We'll call that push block command. And then we'll take push block command dot execute. There we go. So we're executing the move command, we're executing the push block command. Everything still works. Amazing. Now it's time to do the fun part, which is to write the turn manager or undo manager. I'm going to call it turn manager because undo manager is kind of a silly name. So I'm going to make a new empty game object, call it turn manager. Should this be in our command system? I guess so. Let's make a new turn manager. How does turn manager works? Turn manager is going to take the code for executing a block and hold on to it itself. Executing a command and hold on to it itself. And it's going to also then, once it has the information of all the blocks that are being, all the commands that are being executed, it'll be able to store them in a list and undo them. So we'll make a list. And if you're thinking, I feel like I know something that could be used instead of a list, you're right. Commands on awake, or reset that to a new list. And then we need execute command. That will take a command. And we need a public void undo command, which will take a command. Actually, list undo on its own, right? It doesn't need to be told what to do. Command.execute. We get a command, and we're going to execute it. As far as this turn manager is concerned, it's only going to know about that parent class. We'll circle back on the undo part in a second. Let's get the player hooked up to it. Instead of executing it here, let's grab a reference to our turn manager. And we'll take, instead of executing it, we'll just do turn manager dot execute command move and turn manager dot execute command push block command. So currently all I've done is just move that dot execute function into this script over here, which is currently unhelpful. But notice how in execute command, I'm giving it an object of type move, and I'm also able to give it an object of type push block. That's because both object of type move and the object of type push block are both derived types of command. So when we give them to somebody as a command object, it won't know about their anything other than what is defined in this class. And it knows that it can execute and it knows that it can undo. In our turn manager, that's all we need to know, that it can execute and that it can undo. And those overridden functions on the children classes, move and push block, are going to run at the appropriate time. So let's make sure that works. Turn manager, add a new turn manager, set this all, zero it out, that doesn't matter. Go to our player, hook up the turn manager into the slot. Sounds like I want a singleton pattern. I think I do. And everything still works. The commands still execute. Time to add this undo feature. First, we'll need to take our commands and add them to our list when we execute them. To undo, we're going to take the command off of the top of the list, take it off of our list, and then undo it. So command latest equals underscore commands dot count -1, something like that. It's going to use this new C#8 feature is what Ryder's going to tell me, right? Yeah, it is. That's a new feature in C#8. We like that. Okay. So we're going to get the latest thing on the commands. We're going to undo that command, and then we're going to take it and remove it from our list. Remove at. Oops, I have to remove it. Yeah, Doesn't matter when I remove it. Haven't removed it yet. I'll remove it at the end. Cool. I can also just remove specifically this one. Instead of using remove at, I can just remove it. There we go. So I add it to my list and I remove it. And that should undo. Let's add an undo function. Let's go to our player, which has our input. Input.get key down, key code.z, turn manager.undo. Right? Our player already has a reference to the turn manager. It's already got all of our input. Seems like a good place to put it to me. All right. The big reveal. Have we added undos? Look at that. Look at that. I move, I can push a block, I move more, I can undo. It's so good. It's so good. In a game like this, are you going to need a maximum number of undos because your turn manager, that list got too long? Probably not. Probably not. You could also get the number of turns and print that on the screen by just checking the length of the list. Fancy. So let's clean it up. Hey, lists are weird. Let's use a stack. A stack is, what is it? Push to the top of the stack. It cleans up this part. Check this out. Cleans.pop. This will take the most recently added item to the stack in a first in, last out way, and it'll get rid of it and it will give it to us. So, just it's a data structure. It's a subtype of list. It's actually it's a subtype of the same thing that a list is a subtype of. But it behaves like a list, but just it's like a little bit more. It has these functions that do exactly what I want it to do, which is I want to add things to a stack and then pull them off the top. Another one worth knowing about is queue, which allows you to add things to a queue and then pull them off the bottom. And first in, first out. Anyway, fun. It's a type of list. Super cool. Great. Let's hook up some buttons to undo with. Right click, UI, canvas, and I'll make a new UI button. It's going to import Text Mesh Pro. Anchor that in the top left, bottom left. Where do buttons go? Where does undo go? Bottom left. At position 0, 0, but I want position 0, 0 to be the left side of it. And then I think we measure off the top left, so that should be 1. Is that right? No, it should be 0. No, I did it wrong. How did I do it wrong? Here's my button. Why is my anchor so far away? Oh, because I typed in 9 instead of 0. There we go. Cool. And then we get a little padding. And then we'll change the text to say undo. And then the button will simply directly reference the turn manager. And it will call the undo function. And I'll make it a little bit less wide. Undo buttons should be not so big. Brilliant. If I can't undo, I get an error. So let's fix that. Commands.count is greater than 0. Great. Nice. So that's the game. So after we learn about event systems, we're going to use a on-turn complete event to allow these little dots to only check when a turn is done, when they should check themselves to see if they have an object on them, if there's a block on them or not. Also, we'll need some way to differentiate the block and the player. If there's a player on those, that doesn't count as victory. Currently, the player is also a block, so it can't be a mere get component. But we'll figure that out. All very easily solved problems. But that is the game. So all this code is going to go up in a GitHub repo, and that'll be linked somewhere around here. But I hope that command pattern helps you make sense of it, or at least see it in action. These two commands are pretty similar. We're just moving, but it's all right. When you're doing a command pattern, think about where you want to implement the logic of the actual verb that affects the game objects, because one thing odd about the command pattern is that in our case, we still want the block really to control how it moves, because this is the place where it makes the most sense to animate. And to turn on a sprite renderer and to change the orientation of a sprite and to do all of that. So being told to actually, hey, do the movement by an external source, wherever it is, and do that, it still makes sense to put that on the block object. Or maybe a different object, probably not though. So the command is it's storing the information about the command, but it's not actually implementing the, pusher.transform equals pusher.transform plus, direction. It's not doing that part, right? But it could. In another implementation with some different game, you might have all of your logic implemented directly in the commands, and that will be fine. I've done that for card games where I just stored all the things. I mean, I think they still told cards to move. It didn't animate them here, but a lot more of the logic was there. The other thing we're not doing is the commands. These commands are things that are successful and are happening. So all of my checks to see if, from my input move, right? If we could rename this to try move, right? Checking my input and trying to figure out if I should move or not. I don't like putting that stuff in the actual command system. I don't like commands that can be successful or failures. That said, the most complicated command system I've ever written did do that. It did encapsulate all of the attempts about it because it used a fancy event system and a bunch of recursive stuff. It's not beautiful, but it's very effective. So I like keeping the commands as simple as possible, as having the actual logic somewhere else and the logic for if it should happen somewhere else. And commands are things that happen. One final note. I know you're like, this is done. Done, not dumb. It's fun to have a multi-command command. So if our multi-command inherits from command, and our multi-command can do something like for each command C in subcommands, C.execute, then initialize that from the inspector. And then we'll do the undo. You could now have a bunch of things happen in one turn that are themselves stored as commands that can be done and executed. You could make them, add them all to a list, make a multi-command out of that list, and then have this one command be the thing that you give the turn manager. So when I press undo on my screen, all four enemies that made a move that turn can undo, and that's like a turn, right? Or I went and then the enemy went, and we undo, and it needed to undo their move and my move. And you can wrap them up in this weird, fun way with that, which is nice, which is cool. But anyway, that's it. That's everything I want to say. And my time, 30 minutes set. Yeah, I am on time. That was my goal for this video. Every second I continue talking is a second I'm going over time. So have a good one.